Okay, ladies and gentlemen, we're down to 3D vectors. Now, 3D vectors are exactly what they intend. They have an X component, a Y component, and a Z component. To graph all those pieces, what we need is something to help us. Now, if we take something like this, and we type in the point 3, 5, 7, and watch it graph it. Okay, so it'll graph that by moving down various axes, 2, 6, -3. Alright, so let's try another one here, plot. Okay, so we go down, over, down in this case. So what we can do is, those are simple points. Now, if I actually wanted to turn this into a vector, all I would do is make my initial point 0, 0, 0 and draw in the vector from the origin out to the point. So it's actually coming forward, over, and up, but my end vector is right where you see it. Now if I do it to the other one, I can come forward, over, and down, which is really the same thing as going straight to it from the origin. So three-dimensional vectors are exactly that. You graph them on the three-dimensional axis. So you would end up with X, Y, and Z. Now, interesting thing about it, depending on your text, your axes may be significantly different than what you think of. So you could have, for example, you could have X over here, Y in the traditional direction, and Z coming out at you. There. So, by rotating your various axes, you can get all sorts of different looks as you create these various vectors. Now, what we need to do is figure out, well, what can I do with them? Well, if I have two vectors, 2, 7, -3, A and B, it works just like the others. To add them together, I simply take 3 plus 2 is 5. 5 plus 7 is 12. 7 plus -3 is +4, and there's the vector between those two vectors. So we can add them. We can subtract them. 6 times vector A can be multiplied. So we come up with 18, 30, and 42. So that's a vector in the same direction but 6 times longer. Additionally, we can do a dot product. So if I do A dot B, I can take 3 times 2 plus 5 times 7 plus 7 times -3 and come up with my dot product. So I got 6, 35 minus 21, so I would end up with 14. 14 plus 6 equals 20. By the way, you still have some of the same rules that apply. So projections, angles between, those things tend to work the same way, just with 3 variables. So 3D vectors, nothing to worry about. So as we look a little forward to it, we have one more topic, if I'm not mistaken, in vectors, and that is the idea of a cross product. Finding a vector that's actually perpendicular. So we will talk about that in the next video.